Hello dear friends, I am Majid Eskandari, and here we want to have an introduction to the definition of three important electrical parameters: voltage, current, and resistance. Imagine a river with water flowing in it. Water moves from the side with higher elevation to the side with lower elevation. The speed of the water depends on the slope of the river and the amount of water present. Now, if we want to simulate electricity, we can say that a wire which conducts electricity plays the role of the river. The volume of water represents the voltage, and the flow of water represents the electric current in electricity. As mentioned, water moves from higher elevation to lower elevation. In electricity, it is the same. Electric current moves from the side with higher voltage to the side with lower voltage. For example, if one end of a wire has 12 volts positive and the other end has 0 volts, the current will flow from the side with 12 volts to the side with 0 volts. Now, if we assume that there are farms along the river that use the river's water for irrigation, in electricity, there may also be consumers like lamps or any other device along the wire that use electricity to power the device. In electricity, voltage is represented by the letter V, current by the letter I, and resistance by the letter R. Each of these parameters has a unit to express its value. The unit of voltage is the volt, and it is represented by the letter V. The unit of current is the ampere, represented by the letter A, and the unit of resistance is the ohm, represented by the ohm symbol. Voltage and current generally exist in two forms, either alternating or AC or direct or DC. In DC or direct current electricity, the voltage and current always remain constant, and the current flows from the positive polarity of the power source toward the negative polarity. But in alternating current, or AC, it is not like this, and the positions of the positive and negative polarities are constantly changing. As we mentioned, the direction of current flows from the positive polarity toward the negative polarity, so when the positive and negative polarities switch places, the direction of the current also changes. If we want to show the changes of direct current and alternating current over time in a graph, the DC graph is a straight line and does not change over time, but the AC graph, due to the changing polarity, has oscillations, and its changes are in the form of a sine wave. The number of times this waveform repeats in 1 second is called the frequency. Here we have an example of a musical waveform that you can see. This waveform is repeating over time until our time reaches 1 second. For example, in this case, up to the 1 second mark. Our frequency becomes 5 Hz. Regarding Iran's power grid, in the context of electrical systems, the standard residential voltage used in most homes is 220 volts, and the frequency is set at a standard value of 50 Hz. This means that our waveform repeats 50 times every second. As we mentioned, DC voltage, that is direct current voltage, remains the same and does not change over time, so the frequency of DC electricity is 0. In electricity, there is a concept called power. Power means the amount of energy consumed or produced per unit of time. Electrical energy or electrical power is generated in power plants, transmitted through transmission lines, and delivered to consumption sites via power poles. Now, these sites can be farms, residential areas, factories, or anything else. Power is represented by the letter P, and its unit is the watt, which is denoted by W. power is consumed in circuits in various forms. It can be in the form of heat, like in heating elements, or as light and heat, like in lamps, or as sound, like in speakers, or as mechanical energy, like in armatures and motors.